15.2, we want to look at some of the formulas that require you to understand the measure of the degree in radians, not in degrees. Or sorry, the measure of the angle in radians, not in degrees. So the first one that we want to look at is this idea of arc length. So it's the relationship between the central angle and the length of the corresponding r. Basically, what I'm looking at is if I have some angle, that was supposed to be a central angle. If I have some angle here, here's my central angle, I want this arc length. And the relationship here, that arc length is going to equal the radius times theta. So that's just a formula that you need to have on your formula sheet. But what's important is theta does have to be in radians for this to work. In example 1, if we want to find the length of the arc, we have a central angle and we have the radius. We're simply going to do 15.0 times pi over 3. Here, it's in radians, so we don't have to change anything. So 15 times 3.14 divided by 3, that arc length is 15.7 feet. If you were walking around that circle, you would need to walk 15.7 feet in order to walk the arc that's defined by a pi over 3 angle. Now, let's look at example 2. Given that a circle has an arc length of 4.6 and a central angle of 120 degrees, find the radius. So here, we know the arc length and we know the angle, but we don't know the radius. One thing that's missing, or we're not quite ready to do this problem yet, the angle is 120 degrees. This must be in radians. So we're going to do pi over 180 here. And so 120 divided by 180, that could be 2/3 pi if you left the pi, or you can go ahead and multiply by 3.14. You're going to get a decimal for these answers anyway. That's the same thing as saying 2.09. So here, we know the arc length, so we're going to substitute S. We don't know R, but we just found the angle is 2.09. So divide both sides by 2.09, and we'll get that the radius is equal to 4.6 divided by 2.09, or 2.2 centimeters. Next, we might also be interested in finding the area of that piece of the circle. So in order to do this formula, you do the area equals 1/2 theta times r squared, where theta is again in radians. So we're just basically finding a slice of a circle with this formula. We've got a circle and I have some particular radius and angle. I can find that area. Here, in example 3, we know the radius, we know the central angle in degrees, so let's convert that. 24 times pi over 180. 24 times 3.14 divided by 180 gives us 0.419 for our angle. So we're looking for the area. It's 1/2 the angle times the radius squared. 0.5 times 0.419 times 36 squared gives us 271.5 centimeters squared. It is a radius, and so that is a square unit. Example 4 is where we know the radius, or we know the area, but we don't know the central angle. We know the radius, we know the area, so we're going to substitute 3.28 in for our area, part of the formula. 1/2 theta, and we know the r, so we'll do r squared. Let's simplify what we know. I'm going to multiply the 0.5 times the 2.5 squared, which is 3.125 theta. To solve for that angle, I divide both sides by 3.125. And 3.28 divided by 3.125 tells me that my angle is 1.0496, or I can make that 1.05. This is in radians. If you wanted the angle in degrees, you could then convert it by multiplying by 180 over pi.